Alrighty, we're going to talk about blood flow within the heart and the electrical conduction system in the heart. So this is my 3D heart model that I made, front and the back. We're going to take off the front to view the interior structures. To start off, we have the deoxygenated blood that's going to come in through the body. It's coming in through the superior vena cava, the inferior vena cava, into the right atrium. We also have the coronary sinus. That's right here. It's going to be number 17. That is going to be the deoxygenated blood from the heart itself. So the myocardium is going to send that deoxygenated blood through the coronary sinus here, and it's going to come into the right atrium. The right atrium then sends all this blood through the tricuspid valve. So you can see that valve here has 1, 2, 3 leaflets into the right ventricle. Right ventricle then sends it out through the pulmonic valve. Again, 1, 2, 3 leaflets. So we have the main pulmonary artery here. This is going to branch into the 2 pulmonic arteries. So we have the left and the right coming out the right side. This is going to send all of the deoxygenated blood to the left and the right lungs. That's going to exchange the carbon dioxide with the oxygen that the lungs just breathed in. It's then going to send that oxygenated blood back towards the heart. It's going to come in through the pulmonary veins here and here. So the pulmonary veins are going to send in the oxygenated blood into the left atrium, through the mitral valve here, and into the left ventricle. As you can see, the left ventricle is quite a bit bigger than the right ventricle, so we're going to have higher pressure, higher volume. We're going to be sending that out through the aorta here. You can see the aorta down below number 12, so that's going to send it out here, up through the ascending aorta, across the aortic arch where we have our 3 branches, and then down the descending aorta to the body. So the branches are going to take that oxygenated blood to the arms, the neck, the brain, and then the descending aorta is going to send it down to the lower body. So that's going to go through the aorta to the arteries, arterioles. It's going to then switch in the muscles between oxygen and carbon dioxide. That's going to be burned off in energy. And then the venules and then the veins are going to bring that blood back up to the heart in through the superior vena cava and the inferior vena cava, and we're going to start that process all over again. Alrighty, now we're going to go over the electrical conduction system. So once again, we're going to view the interior structures. We're going to start with the sinoatrial node, also known as the SA node or the pacemaker. It's going to be located right here in the right atrium. It's going to send an electrical signal through the atria, so it's going to cause the atria to contract, send the blood down through the ventricles. It's going to send that electrical signal through the atria to the AV node. That's the atrioventricular node. It's located between the atria and the ventricles. So that AV node is going to delay the signal just slightly so that the blood can fully drain from atria to ventricle, and then after it leaves the AV node, it's going to travel down through the bundle of His. The bundle of His is going to divide the electrical signal into the right and the left bundle branches. So it's going to go into the respective ventricles here. And that's going to lead to the Purkinje fibers. The Purkinje fibers form a network through the ventricles, so it's going to rapidly send that electrical signal to both sides, and it's going to stimulate the ventricles at the same time, and that way they pump the blood out at the same time through the aorta, through the pulmonary arteries, and it's going to go to the body and the lungs. And that completes the electrical conduction system and blood flow through the heart.